This video is used for an example calculation for determining absolute zero, and what I noticed in doing so was that towards the very end it takes out, or I couldn't record that one last data point, so that's why I'm using it just for this example calculation. And so I'm gonna go over to Excel, for example, and plug in the data, and those were 96 degrees Celsius and 8 degrees Celsius, and for the 96 degrees Celsius I measured 17.8 psi, and for the other one, 8 degrees Celsius, I measured 14.1 psi. That was the data point, it cut it out, but remember that these are my data for the example calculation. These are not your data. You have to use the next video. Okay, there are basically three methods on how absolute zero can be determined for this. First, I'm going to show you the quick one. Notice that between 96 and 8 degrees Celsius, there's temperature difference of 88 Celsius degrees, and between 17.8 and 14.1, there is a temperature difference, a pressure difference of 3.7 psi. And here's what I'm going to do is I'm going to go downwards here, so I keep subtracting 3.7 from the 14.1 consecutively, so 10.4, 6.7, and 3.0, and then I don't exactly hit the zero here, so I have to do a fraction, and I want to say in the neighborhood of, kind of looks like 80% of that. Okay, so as I go down here in pressure down to zero, I'm also going to go down here by 88 degrees, so I'm going to get up here at negative 80, and then negative 168, and then negative 256. I'm doing this in my head, so I hope I don't make a mistake. And then I'm going to do, as I said, from here to here, that's not exactly 3.7, it's about 80% of 3.7, so I'm going to do 80% of that, which is in the neighborhood of another 70 or so, so I'm going to come up with negative 326, and that would be my result, negative 326 degrees Celsius. That is the quick method. There's another one that I can do, so let me show you that one, and that's where I take these data and I'm going to graph them with a scatter graph, and then here's the scatter graph, and I have to do something with it. Among that is that I have to turn the data around. So select data, and this is the newest Excel, switch row and columns. Okay, alright, there we go. And then I have to change this, I have to move this in here. I have to change the x-axis, and I want to change the minimum to, well, somewhere around negative 350, and the minor unit I want to change to about 10 degrees, and that should show as well on the outside. And then I get this one here, so, and then wherever this line here, I put a trend line in here, that's what it's called, and it will be linear, and I display the equation on there, and then I have to extend that straight line so that actually hits zero down there where the pressure is zero, and that's where we should have absolute zero for the temperature. And I checked this earlier that apparently I have to add 500 periods backwards, and then it stretches that line here, and we can see that it hits approximately here's negative 350, negative 340, negative 330 approximately is the absolute zero, and of course that's what I had earlier, so negative 330, and if I make this one in bold here, and if I make this one in bold. And a third way of doing it is to take these numbers here and solve for x. That would be, and with the y here being 0 psi, solve for x. So I'm going to get the 13.76 to the other side, so negative 13.764, divide by the slope of 0.042, and I come up with around at negative 328 degrees Celsius. And not that you have to do it 3 times, but I want to offer you 3 different ways of doing that. 2 of them involve the graph, if you can do it in Excel, and this one here, calculation. And this one here, as I said, is the quickest method of just counting down with what I showed you in probably the first minute of this recording. Any one of them gives you around negative 330 degrees Celsius for absolute zero, and that's in the neighborhood. It's not the exact negative 273 kelvins, but remember, this is an experiment that was only accurate to like an estimated tenth of a psi, as I tried to read of the scale on the pressure bulb. In the data that you have on the next video, you're actually going to come somewhat closer to it. But as I said, do the same kind of calculations that I did here, either the quick method or the graphical method as I showed you here.